And welcome back. As we go ahead and continue to dive into C++, let's go ahead and look at how C++ now handles functions. So there are two types of functions in C++. We have standard library functions, which are predefined in C++, and we have user-defined functions, which are created by users. The syntax, of course, to declare a function is pretty easy. We have the return type, followed by the function name, and then any parameters. And then we have inside of the curly brackets whatever body of code we want to execute. So this is a quick example of a function declaration. So let's just say we have a function called greet, and all it's going to do is do a cout message that simply says hello world. Now, if we want to actually look at calling a function, we first need to call that function or invoke it in our code in order for that to actually work. So if we want to use that greet function that we just looked at, we can use it as follows. Int main, and then of course we would then call the function with this simple line greet, open and close parentheses, because again, no parameters. One thing you'll note is that defining a function though has to be done outside the main. You can of course define it inside the main method. Let's all go ahead and take a minute to examine some of those function parameters. Now a function can be of course declared with parameters or arguments, as they are often referred to. A parameter, of course, is a value that is passed when declaring a function. So if we look at this function below, we have void print num, int num, cout num. The parameter, int num, is the argument that will be used by the function. Int, of course, is specifying the type, whereas num is the name of the local variable being plugged into that function. Now, there, of course, is a distinction here in C++ between return functions and void functions. Functions in C++ can either return as void type or as a specified return type. In the latter, we of course use the return keyword to return whatever value we are expected to have. So for example, if it's an integer, it should be a return that is going to return an integer value. So in this example, we have int add, int a, int b, so it's a parameterized function here. And we're going to simply say return a plus b. All that's doing is simply just adding up those two numbers and returning the value. And we know that because a and b are both int types, that matches what the function is, in this case, an integer. You also note that when we put the keyword return in here, this indicates that the function has ended. You're not going to have anything past that point in terms of code. Only exception to this might be if you had some kind of like if statement or something like that that's going to return it early, which in case if there is like an if statement that does have a return statement in it and the if statement does trigger, that means anything that's after that if statement won't execute. Now, we also need to discuss this thing called function prototypes. Unlike in Java, function definitions should be declared in your program prior to their invocation, which means the main method should always be last. However, if we want to define a function after the function call, we need to use the function prototype. So you can kind of almost think of this as when we start looking at Java like interfaces and stuff like that, and some of the method stubs that we might create. This is the kind of similar thing. So here we have a function stub, if you will, of void add int, and so it's saying we're expecting to have a void function called add, and it's going to take in two integer types. Then, of course, we can use our main method as normal, and then we can define the function after the main, because C++ knows, oh, you're going to use this add function that you kind of gave me a prototype definition for before, but now the actual definition exists below. This is, of course, if you're much more comfortable with seeing your functions come after your main, this is a great way to do it. Or if you want to simply start defining those functions so you can write out your main code and not have to worry about what all the logistics of what that function is going to be, this is a great way to approach some of that. Now, real quickly, I'm just going to discuss a couple of those predefined functions that C++ have. So those functions are built in, which means you don't have to go and create them. Now, some of these common library functions that might come across are things like square root, absolute value, is digit, etc. So in this quick snippet, you can see we have double square root, and the number equals 64. And all we're going to do is we say, well, we want square root to be equal to sqrt of number. Sqrt, of course, is the function that is built into C++ that we can then use to plug a value in and have it solve for us. Now, we want to use library functions. we are also going to need to include the header file in which these library functions are defined. Think of this as like in Java when we'd have to import things like our scanner class. We have to say, hey, we want to use this specific thing. We need to import that in. So instead of using an import statement here, we're going to include in the header file those particular libraries we want. So for example, if we want to use things like square root and absolute value, we need to include the header file cmath. All right, and one last thing to kind of touch on is function overloading. Like Java and other similar languages, C++ can overload a function. So in here you can see we have 4 different functions that are all, of course, having the same name but different arguments. So I have int test, int a, float test, double a, int test, int a, comma, double b. These all are effectively different functions. Now remember, overloaded functions may or may not have different return types as well, but they must have different arguments. So if we start looking at this, you can see I have an argument that is a no-arg function. We have a single argument int a. We have another argument here, double a, and they have one that's int a, double b. So let's go ahead and pop on over and see how this actually looks. So here I've created a quick demo program that can create some of that demonstration with overload functions. All these functions you can see are a add numbers function, and they have different code in them based upon what I want to do. So for example, in this no-arg function, because I'm not passing in any parameters off the get-go, I need to then take those 2 integers and have them actually be gathered inside of that function. In this parameterized version though, you can see I can get those in my main, and then I can pass them in as parameters here that can then be used to give a single line of code. Now with a return value, one of the things you'll notice here is that we can then simply just spit this out with a return value, which means we're not going to immediately write it out, but we can then use this in other things. So if I were to look at the actual code here that's going to call this version of add numbers, you can see we have a cout statement, and then we can invoke that method directly within that cout. So it gives us a little bit more power functionality. There are, of course, times when having a return function might be more valuable than that of a void function. Now, one thing you will notice is that these are both called add numbers, which means this is technically, right here, not an overloaded version of that function because it's saying that these are 2 different letters. If I change this back to add numbers with a lowercase a, you'll notice I do get an error here. And when I get that error, what is one of the things that happens? It says I don't like this because we have the same number of parameters. Now, if I were to come in here and change one of these to a double, then of course it would work. But down here we have a undefined value now because I have to fix this to add numbers. But we still have other issues because now we're expecting this to be an int and a double. But what are we passing in? We're passing in, of course, 2 integers. So I think just for our purposes, just keeping this as a non-overloaded version of that function is perfectly fine, because we do get a nice good overload demonstration right here. So let's just give this a quick run here to see what exactly this function is going to look like. All right, and so it tells me to please enter 2 integers to get started. So let's just go ahead and enter 5 and 4. Now it says invoking the no-arg version of add numbers. And so in here, this of course wants us to re-enter those 2 integers. So I'm going to enter 5 and 4. And now we get the sum of the 2 numbers is 9. We're invoking the parameterized version, which is this right here. And again, notice it immediately spits right back out, returning the version, even the sum, and then we jump right into return to the return version. And again, we get the sum is 9. All these functions produce the same thing. So it's kind of a nice demonstration to show you that there can be more than one approach to how you implement these functions, and which is not very dissimilar to other programming languages that we've looked at.